লাইনেও করা যাবে না, যেহেতু একটা কন্ডিশন এসে গেছে। তোমরা চাইছো ঠিক আছে, কিন্তু আমিও হয়তো আমার অসুবিধা নেই, কিন্তু এইটা একটা মুশকিলের জায়গাও আছে আর কি। তো সেটা দেখো, সেটা কথা বলে, না হলে কিন্তু আমাকে ওই শনি রবি নিতে হবে। হ্যাঁ, সে মাঝে মধ্যে হয়তো আমি করব, আমি কোনো ধরো এই বললাম এই শনিবার হবে না, আমি আজকে সোমবার বা যেটা তোমরা বলছো মঙ্গল, আমি 5:30 থেকে নিয়ে নিচ্ছি 2 ঘন্টা, তাহলে ওই উইকটা মেকআপ হলো। এইভাবে মানে ওই কন্টিনজেন্সি ম্যানেজমেন্ট, কন্টিনজেন্সি মানে ফিক্সড কিছু থাকলো না, কিন্তু গ্যাপে গ্যাপে করে আমরা ক্লাসটাকে এগিয়ে নিয়ে যাব। আমি বসি হচ্ছে ওই ডিন এফিটি যে দোতলায় ঘরটা, এফি ইন্টিগ্রেটেড বিল্ডিং, ফরজিং ফরজিং
আচ্ছা
সঙ্গে
আচ্ছা,
ডিন এফিটি ও
প্রোডাকশন যেখানে আছে তো,
প্রোডাকশন
যেখানে
বিল্ডিং এ
প্রোডাক্ট।
ডিনের
হ্যাঁ
অফিস, ডিনের ডিনের ঘরটা ঠিক ওপরে 3 তলায় আর কি, মানে ডিনের ঘরটা দোতলায়, সিঁড়ি দিয়ে উঠে গেলে 3 তলায় উঠেই যে সামনের ঘরটা, মানে ওই ওই বিল্ডিং এই।
আচ্ছা,
ওই
ডান দিকে গেলে তো ক্যাডের ঘরটা।
না,
ডান
ক্যাডের
দিকে গেলে।
ক্যাডের ঘরের ডান দিকে, আর ওই সিঁড়ির ওটার মুখেই যে ঘরটা আছে একটা,
ও আচ্ছা আচ্ছা, হ্যাঁ
ক্যাড
বুঝতে
তো
পেরেছি
সিঁড়ির উঠেই একটা ঘর, মানে দরজা
হ্যাঁ।
কোলাপসেবল দরজাটা আছে। ঠিক আছে, আজকে বোধ হয় আর কেউ আসবে না, তাহলে আমরা একটা রেমেডিয়াল ক্লাস হিসেবে ট্রিট করি। Later on you share the contents to your other students also. And next week আমরা ফ্রাইডে 1টা থেকে 2টো সেটা তো থাকছি। এই মুহূর্তে আমি সোম মঙ্গলের কথাটা বললাম না, ওই শুক্রবারে ক্লাসে গিয়ে বাকিটা আলোচনা করা যাবে। আচ্ছা, 1 মিনিট আমি। So we had probably discussed up to the various precision or investment costing techniques, the lost works process, and so on. Now today we shall discuss the gating system. So in the last class, most likely, we had mentioned about a figure of gate, is not it? Pouring basin, down gate, ceramic strainer, splash core, skim bob, or whether those were discussed.
Yes, sir.
So one figure was there. So quickly we may also go through that figure. This figure was discussed. The pouring basin, down gate, there is a strainer or ceramic dross removal system. Dross means oxide, layer of oxide scales, nitride oxide, sulfur oxide, etc. Splash core to avoid the erosion. This is the screw base well. This is known as this one. Now, if there is sharp corner, then this portion may be damaged when the molten metal will be poured from elevated height. So it will have a velocity and pressure also. So that velocity and pressure will just what is called is wash out all these. Okay, all these particles will be washed out. Sand erosion, like say a river bank is eroded by the flow of water in the river. So we provide a splash core. This will minimize the eroding effect, and also the during the design, this sharp corner should not be there. So all these sharp corners must have to be carved. Okay, so filleting is needed. At this particular portion, this horizontal, this is actually the runner. This is actually the runner, but this is down gate. This horizontal portion is actually the runner, and there is a trap, metal trap. It means some lighter impurities will be floated on the upside, whereas the heavier impurities will be deposited in this downside. So this is half circle, another half circle. So this is a skim bob, known as a skim bob. This is a trap of the impurities. Then more purified material is finally entering through this in gate. This portion is the in gate. So this is the in gate, and this is the cavity. So this is the total gating system. But in the figure, when we draw the figure, so we simply uh, label say this as a runner, but actually the runner portion is this horizontal one. Okay, so here again a gating system and a riser, mold cavity, all these are shown. There are two hubs, scope and drag, aligned by guide pins, and uh, this is the mold cavity, green color, where a core is there. What is core again? Today we shall discuss. And this is the pouring basin or cup, down gate or sprue, and there is the sprue base well. This is also known as sprue base well, where there are this that splash core and all these ceramic strainer. This is not shown here. We may have a skim bob here also. This is also not shown, but separately we had discussed. There is a ceramic strainer, there is a splash core, and there is a skim bob. So for the simplicity, we don't draw all these in a single diagram. But if it is asked that discuss the gating system drawing a neat figure, so then you will have to discuss this part, right? Pouring basin or cup, down gate or sprue, ceramic strainer, splash core, sprue base well, and this is the skim bob. Then finally ingate. Finally, this is the ingate. There is other part, riser. So again, we shall discuss about riser. What is riser, right? So to produce this runner and riser, where riser is nothing but the reservoir of molten metal, because when metal will be solidified, how it will be solidified? Metal will be poured from very elevated temperature, and gradually it will release heat to the atmosphere or to the molding sand, surrounding molding sand. So releasing heat, it will be solidified, because from very hot condition, it will become cold. So when the heat is released, then the metal from molten state, it will become solidified, right? So during such solidification, all the metals have a property known as shrinkage. When it solidifies, it will shrink in volume. Okay, that is contraction in dimension will be uh, resulted. So if the dimension is reduced due to shrinking, then our required dimension or object will not be fulfilled. I have designed something. Accordingly, I have prepared the core, sorry, cavity where molten metal is poured. But after solidification, if the dimensions are reduced due to the shrinkage property of molten metal, then our target will not be achieved. So during such solidification, due to shrinkage, okay, at that time, if some extra material can be supplied, then this shrinkage can be avoided, right? So that is the function of riser. It is the reservoir of molten metal. And there are different types of risers. So after some time we shall discuss. So this is the gating system: riser, runner, pouring basin, all these. Now gate, what is it? বলো।
আর স্যার ওই যে ওই চোখের ওখানে যে ওটা কার্ভটা আছে ওটা কি ওই ইমপিউরিটিস গুলো ওখানে গিয়ে
হ্যাঁ,
এই
এখানে why pouring basin is needed? Why pouring basin is needed? Last time in the last class also we had mentioned, if a cup shape is provided, then the impurities, heavier particles, will be deposited here. Okay,
ইয়েস স্যার
and comparatively pure lighter metal will come down. Here, some heavier particles will be arrested in the basin. So, the technique is to pour molten metal not directly here, pour in the pouring cup or basin, so that the heavier impurities can be settled. Comparatively pure metal will flow here. Then oxide scales will be arrested here. More pure metal will enter here. Again, if some impurities still are there, so that will be arrested in this choke area, screw base well. But we also provide a splash core in this well. Splash core, like say this is a core, so that is prepared separately using core making sand, and it is placed here. Okay, to avoid the eroding effect.
ইয়েস স্যার
So all the time the cup, why this cup shape is provided? Just to pour the molten metal in the cup so that heavier impurities can be settled. If on the other hand, if you pour directly through this space, then that will directly come to this area. So that is not desirable. That's why I always pour the molten metal in the cup area. And that's why the cup shape is provided. In the workshop video or workshops also, right now you are going to the workshops. So that time also you will produce this cup shape, a funnel shape. Now, what is a gate actually? Gate is actually the passage, entry point through which the molten metal finally enters into the cavity. So that is the gating system. And as we have already discussed, it includes pouring basin, runner, gates, that is in gates, etc. And these are some important points desired out of a good gating system. What are the requirement? Metal should flow, because when metal will be poured, it will have a turbulence. You know what is turbulence? If you open a tap in the water basin, then a whirling motion will be generated. So that is the turbulence. So similarly, if I pour molten metal on the cup or basin, a whirling effect or turbulence will be generated. And if turbulence is there, air or other gases will be entrapped in the molten metal. And finally, that will go to the mold cavity, and there will be various defects due to the dissolved gases. Today again we shall discuss the defects. And also, so gate should be designed in such a manner so that turbulence is minimized. Also, erosion is to be prevented, as we have discussed, and gas pickup, that is, no extra gas from outside environment should be infused with the molten metal, because turbulence results air aspiration and dross formation. So that's why these are the requirement of a good gating system. Second requirement, temperature gradient of molten metal should be well adjusted. It means if you pour the molten metal very slowly, then obviously the turbulence will be reduced. Chance of erosion will be reduced. But if you take long time to fill the cavity, then it may happen by that time the metal will already start solidifying, losing the heat. So that may create some other problems. On the other hand, if you pour very quickly, rapidly to avoid solidification, then also very quick pouring may result a huge amount of turbulence, gas pickup, erosion, all these. So there should be a balance. So this is the concept of temperature gradient. Okay, so gate should be so designed that this temperature gradient is maintained. That is, not too fast pouring, not too slow pouring. Optimums, what is known as optimum. Mold cavity should be completely filled up with the molten metal in shortest possible time, but not too fast, because if it is poured very rapidly, other problems like turbulence, erosion, all these will be there. Casting should be produced with minimum of excess metal in gates and runners. Now what happens, say if this green is the cavity, so I require this shape, a green portion, a cup like shape. But you just observe, metal is flowing from this sprue, there are riser, all these. Here is again a riser. So when metal will be poured, metal will also take some, so metal will also be enter in this portion. Here again there are metals. So after solidification, with this main part, green shape, some other protruded portions will be there. These are due to riser, gates, and etc. So point is, casting should be produced with minimum of excess metal in gates and runner. So it will be there, but it should be minimum. So after solidification, after the cast is taken out, then it will have to be cleaned, breaking the extra material, removing the excess layer of metal, and there are techniques. Then gate should be designed so that loose sand, oxides, slag, slag means where impurities are dissolved and it will float on the molten metal, and those should not enter into the cavity. And for that, we are designing gate. We have already discussed there are strainer to remove oxide, loose sand and other impurities can be minimized just by providing a pouring basin or cup. In the sprue base well, erosion effect will be avoided. There is a skim bob to trap lighter and heavier impurities. So these are the requirement. Erosion should be avoided. That's why we are providing a your uh, splash core in the sprue base well. Also, to decrease the velocity of metal flow inside the mold cavity. Why? Because when molten metal will be poured from elevated height, it will have high temperature, high velocity, high pressure. That is, both pressure, velocity, temperature are all very high, metallostatic pressure, because it will be poured from a very top level. And if it is poured very rapidly, then again velocity will be further increased. But this will uh, your erode the uh, your gate and all this mold cavity, all this. So velocity must have to be reduced. Okay, and
Yes.
also premature solidification is to be avoided. Premature solidification means, say, when the cavity, this is the cavity, metal is entering here, okay, before fulfilling this portion, the solidification has been started. So in that case, metal will not be entered in this some portion, so that will give some defective part. So premature solidification is to be avoided. So these are the requirement of a good getting system. So these are the elements we have already mentioned. So pouring cup, sprue, this is cup, down gate, or down gate is also known as down gate. Sprue base well here. Here you observe clearly which is the runner. And finally, these are various ingates. This is the mold cavity, a large cavity. That's why not a single point, but number of entry points are there. Okay, so these are the ingates. These are the entry point. This is runner. So these are the elements. Now again there are, so you will have to draw all these if it is asked that drawing a getting system, discuss about the various components. So you will have to draw this strainer also, this core also, and skim bob. Here there will be a skim bob like this. Okay,
স্যার ওই রানারটা এক্সটেন্ড কেন করা হয়েছে স্যার?
এটা রানার এক্সটেনশন হয়েছে যেহেতু ধরা এই পর্যন্ত যদি থাকে, তাহলে metal is coming, but it may happen, not necessarily. Uh, Sometime it will not be, this portion may have a gap, minor gap. So metal will flow totally through this portion, through this portion, but partially this may become void. So if you extend this portion, so metal will flow throughout this cavity. So easily this channel will be completely filled with molten metal. Otherwise, if it is constrained up to this portion, then maybe the total say ingate may not be fulfilled, or the flow may be minimized to some extent. That's why this is having some extension.
আচ্ছা।
So these are again some discussion. all these had been discussed. We have discussed this thing. Now, depending on the position where the gates are provided, right? There are different types of nomenclature, like a horizontal gating system, vertical gating system. Here, this is horizontal gating system because metal is entering horizontally. On the other hand, if this is considered, again, this is a horizontal, this is not vertical. Metal is entering horizontally here. But if sometime metal may be poured directly from the top, not in this figure, it's in some cases. So that is the vertical. So depending on the position, it may have or orientation, either horizontal or vertical gating system. And you know what is parting plane. What is parting plane? If I have cope and drag hub, say I have cope and drag hub, then this plane is known as parting plane.
Yes.
So if the gate is provided horizontal to the parting plane, that is horizontal gating. On the other hand, if the gate is provided like this, vertical, vertically it is entering. So vertical, so with respect to the parting plane, either horizontal or vertical. And also, depending on the position, it may be top gate, bottom gate, parting gate. What is that? Say, this is the mold cavity, right? And metal is flowing or entering from the top. This is the pouring basin, down gate, screw base well, and it is entering in the cavity from the top. That is parting plane. This is the parting plane. So it is entering at top. That's why this is known as top gate. Sometime this may be also the figure. Top gate. This is horizontal.
ওটা
This is
vertical
vertical.
gate হতে পারে।
But this is not desirable sometime. So this is top gate because it is entering in the cavity from the top of the parting plane. Here, same figure, same arrangement, but metal is entering from the bottom. So that's why this is bottom gate. And here again, same cavity, but metal is entering at the midpoint or at the parting plane. This is the parting plane. If it is divided in two equal halves, okay, so cope hub, drag hub. So this is the parting plane. So the gate is entry point is provided here at the parting line. So this is known as parting gate. Another is also possible. Say for very large casting, thick, not large, say thick. Say this is the thickness.
হ্যাঁ স্যার, কিছু শোনা যাচ্ছে না।
Hello, 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 hello.
হ্যাঁ স্যার,
শোনা যাচ্ছে?
হ্যাঁ
Hello.
এখন শোনা যাচ্ছে স্যার।
না
এখন
ওটা,
শোনা যাচ্ছে
হ্যাঁ
স্যার।
ওটা ওই ইয়ে আসে, ওটা বোধহয় ওই কতগুলো এই বিজ্ঞাপনের কল এসে গেছিল মনে হয় একটা। এখন শোনা যাচ্ছে? হ্যালো?
হ্যাঁ হ্যাঁ, শোনা
হ্যাঁ স্যার,
যাচ্ছে।
এখন ক্লিয়ারলি শোনা
হ্যাঁ।
যাচ্ছে স্যার।
So, if in this, if the thickness is very large of the casting, then only top gate or only bottom gate or only parting plane gate may not fulfill the cavity very systematically. In that case, number of points or number of ingates are provided throughout the height of the job or cavity. That is the concept of স্টেপ গেটস, স্টেয়ার স্টেপ, সিঁড়ির যে স্টেপগুলো হয়। সো দিস আর নোন অ্যাজ স্টেপ গেটস। ওকে, সো উই হ্যাভ টপ গেট, bottom gate, parting gate or parting line gate, and step gate. Step gate. Okay. So
ইয়েস।
after solidification, how it looks like? This is the getting system, mold cavity. So when the metal will be solidified, all these portions with a figure we shall discuss. Just a minute. Where is that? আচ্ছা পরে একটা আছে, পরে দেখাচ্ছি। So after solidification, how it looks like the actual. So after solidification, the job looks like this. This is not the, this is a sketch, but actual figure. So the task is to remove all these extra material. So that is the function of cleaning, casting cleaning. And again, we have a concept that is known as getting ratio. Getting ratio is nothing but AC is to AR is to AG. What are that? What are those? It is it is the area of the sprue base well or choke. You just remember the choke here, sprue base well.
ওকে।
Cross sectional area of this sprue base well or choke is to AR, total cross sectional area of the runner. Total, not a single. Choke area is a cup like. So area of the cross sectional area of the choke is to cross sectional area of the total area of the runner is to total ingate, cross sectional area of the total ingate. If I have three ingates, three ingates, each are having say cross sectional area small a, so 3a will be the ingate area, right? So this ratio is actually the total choke area is to total runner area is to total ingate area. And what is the meaning? If say ratio is like this, say for example 1 total choke area 1, total runner area 2, total gate area 1, or 1, 0.75, 0.5. This is a pressurized gating system. Pressurized means you just observe the in-gate area is zero point 0.5, but on the very back side of this in-gate there is runner and choke where area is much higher. So more metal is accumulated. That is, they are applying a pressure on the smaller in-gate area. So that is a pressurized gating. So if the total gate area is smaller than the than their predecessor, that is runner or choke gate, then this is called a pressurized gate. Here also, total in-gate area 1, immediate predecessor, that is runner, is having more cross-sectional area. So these are pressurized gate. On the other hand, if the ratio is this 1 is to 3 is to 3 or 1 is to 1 is to 3, okay, here 1 is to 1 is to 3 means this is a non-pressurized or unpressurized gating system. No back pressure is existing. No back pressure is existing. So depending on this pressurized and unpressurized, what happens? Uh, Pressurized gating system is associated with your more increased velocity, okay, through the gates, but that will ensure uh, the flow of metal very nicely. On the other hand, if it is unpressurized, then the metal may be stacked in the gate. It may not flow very smoothly. And also, it is required, whether it is to be unpressurized or pressurized, that depends on the type of metal. Like, say, here, normal metals, that is non-ferrous, brass, steel, non-ferrous, no, normal means which are normally used, brass, steel, aluminium, etc. They use unpressurized. That is, gates are larger in gate. Whereas some pressurized system, say magnesium alloy, some reactive material, or some material where it is required to have pressurized system. So this is nothing but to control the flow of molten metal inside the cavity. Okay, so pressurized and unpressurized. So what are the some advantages, and these are mentioned. Okay, pressurized controls the flow. Unpressurized is a choke control system. Okay. In pressurized, metal velocity is high, as I have mentioned, and also turbulence will be there due to high velocity. In case of unpressurized, turbulence is produced and streamline flow is induced. Is not produced, is reduced. এটা ভুল আছে. Pressurized system consumes less metal because I am applying, forcing metal to enter into the cavity. So these are some advantages and disadvantages. As I have mentioned, in case of unpressurized system, flow is not full because metal will be stacked in front of the gate. It may not uh, flow into various intricate carved portions. Like in the other day, during our centrifugal casting and all these, we had mentioned that, or there was a uh, say die casting system where some pumps were used to force metal, and if pumps are used or centrifugal force is applied, the metal will flow to fulfill each and every nooks and corners of the shape. Similarly here, if it is a pressurized system, then every nooks and corners will be fulfilled by the metal. But if it is unpressurized, it may not be so. And here, this is a time temperature curve indicating the various stages of metal pouring, that is pouring temperature. When molten metal is poured, that is in liquid state, molten state. So that is very high temperature. So that is pouring temper, very high temperature. And then this time is liquid cooling, that is molten metal gradually releases heat. So if molten metal temperature is say 1200 degrees centigrade, when it is releasing heat, gradually the temperature is coming down. So it will take some time. And when say particular temperature TM is known as freezing time. And this time and temperature, all these depend on the particular metal, varies from metal to metal, not same for all the metals. So here freezing starts, freezing again, it is not instantaneous. So it will take some time. So during that time, no further decrease of temperature accomplish, will be accomplished. So it is a constant, and this is the point when freezing is completed. And then from this point, cooling of the solid. So freezing means from molten metal, it is now becoming solid, but still the temperature is very high. Say 1200 to 600 is the freezing, and then 600 to room temperature. So to come to the room temperature again, it will take some time. Now these lines are different. This is liquid cooling and this is solid cooling. So this is the freezing point. So solidification is completed here. So this is known as solidification time. Local means actually the solidification is started from the freezing point. So that is the local, but I consider the solidification not from this point, but when it was poured at very high temperature and when the solid is produced. So this is the concept of total solidification time. But actually, solidification is started at this point. Is it clear?
Acha.
Any doubt? And
No, sir.
after solidification, it is cooling down, leaving heat, and room temperature is achieved.
Okay.
Yes, sir.
It's simple. And during such solidification, due to the due to the property of metal, shrinkage will be generated. Shrinkage, right? And shrinkage, how to avoid shrinkage? Allowances are given on the pattern. So later on we shall discuss. Now again, flow of molten metal. If I consider this is a gate, so there are various theorems of all these are fluid flow. So you are familiar with fluid flow. So Bernoulli's theorem, right? Bernoulli's theorem. That is,
Yes, sir.
uh,
Yes, sir.
Yes, sir.
yeah, that is, if we consider uh, a frictionless and no turbulence, that is ideal situation, then this is the Bernoulli's theorem, where the heads, various heads, height and pressure head, velocity head. So this remains constant. So that is the Bernoulli's concept. Total head remains constant. So this is the head due to height, pressure head, velocity head. So if I consider Bernoulli's theorem in 1.1 and point 2, this is the pouring basin. At a surface, there is a point 1, and at this point, uh, this is the sprue. So again, one, two, three different. This is the parting plane line, and different heights. These are the different heights, right? So this total height, HC, H2, and all this. So if I apply Bernoulli's theorem in different points, okay, so pressure head remains constant. From that, we are getting all these equations. So at this point, height is H1, pressure is P1 by rho g. Rho is the density of the fluid, g gravitational force of attraction. V1 is the velocity of fluid at this point, equal to H2. That is the energy balance equation actually. So at
Yes, sir.
H2 is the height at this point, P2 by rho 2, V2 square by 2g plus F. F means the frictional drag. So when fluid is flowing, during relative motion of two bodies, there will be a resisting force against that motion, that is friction. But for the simplicity, we don't consider this F, so we assume F as 0. Okay, and also we are assuming the system remains at atmospheric pressure, no turbulence, no friction. So if that is so, then we may modify. If we consider this remains at atmospheric pressure, that is at both 1 and 2, the pressure remains same. If it is not so, then we will have to write the actual pressure. So if we consider pressure remains same, then what happens? And friction is 0. H1 plus V1 square by 2g equal to H2 plus V2 square by 2g.
Yes, sir.
H1. So at 2 points, following energy balance equation from Bernoulli's theorem, we can write this thing. And also, so this is one Bernoulli's theorem. Another theorem is continuity of
Yes, sir.
mass flow,
Continuity
that
equation.
continuity, because concept is same amount of volume remains constant,
Yes,
constancy
sir.
in volume. So what total fluid is entering here at point A, it will remain the same at point 2 and point 3. So that is the continuity. Volume constancy. Volume remains constant. So if volume, so what is Q is the volumetric flow rate. Volume Q1 equal to Q2. Volume at point 1 equal to volume of fluid at point 2. And what is Q? Q is given by cross-sectional area times its velocity. Cross-sectional area say centimeter square and velocity is centimeter per second. So continuity volume flow rate centimeter cube per second means the rate. That's why the formula is A1 V1 equal to A2 V2 equal to A3 V3 and so on. So this equation is also applicable. So Bernoulli's theorem, continuity equation, and same thing applying Bernoulli's equation 2.2 and 3 as we have mentioned.
Yes, sir.
Okay, and if P2 equal to P3 and P3 are not same, then we may obtain all these equations, and this is from continuity equations. So in this way, so many mathematical juggleries. So all these are nothing. So we can develop so many mathematical models. Again, same thing. If we consider atmospheric pressure, just here P2 and P3 are not considered as atmospheric, so different. And accordingly, we have developed something. But if P2 equal to P3 equal to atmospheric pressure, then those terms can be removed, and accordingly we may get all these. So
স্যার
don't
ওটা
worry.
তো লাস্ট একটা V3 টা তো টরিসেলি ইকুয়েশনের মতো লাগছে।
কোনটা বলো তো?
V3 equal to root 2 GHT.
হ্যাঁ, এইটা আলটিমেটলি ওই এ তো এখানে
টরিসেলি।
বলাই আছে, বাট টরিসেলিস থেকেই এসছে। বাট ভি থ্রি ইকুয়াল টু √2 GHD, এখানে এটা দেখায়নি, ডাইরেক্ট পুট করে দিয়েছে।
হ্যাঁ ওই যে একটা ছিল স্যার, ওই
হ্যাঁ,
একটা পেটের মধ্যে নিচে একটা হোল
এটাও
করে দিল।
আমরাও ডেভেলপ করতে পারি, এখানে আমরাও ডেভেলপ করে নিতে পারি, অত আর ডিটেলসে যাইনি। হ্যাঁ, করে এইসব আসে। ইট মিনস
হ্যাঁ
দ্যাট হোয়াট আই এম ইন্টারেস্টেড টু সে, দেয়ার আর actually get design techniques. So what I would like to say, gate is not that very simple part. There are so many design considerations, but we shall not discuss in detail. If sometime during your third year, fourth year, there will be some projects, major project, minor project in your curriculum. So during that case, if you consider uh, that you may develop something on this, so that is the possibility. Okay, get a design. Again, all these I am not discussing in detail. Just think, you should remember, during get design we are considering the Bernoulli's energy equation theorem, energy balance, continuity equation, as well as this is also important, Reynolds number. All these are the basis of fluid flow. What is Reynolds number? This is important because uh, this will give you the indication of turbulence. You have already mentioned turbulence is very important to be considered, because turbulence may erode the various mold cavity and all these. Air aspiration is also associated with turbulence. So that's why it is very important. And it is associated with a number known as Reynolds number. So how it is given? Reynolds number is given by V d rho by eta, where, or may have some other expression, but in this case,
Yes.
same thing, but the legends may be something different. But what are the meaning are same. V is the velocity of the metal or fluid that is used. In our case, we are interested with metal. So metal in molten state, that is a fluid. So that is the velocity of the fluid. And d is the diameter of the duct through which it is passing. Sometimes it may be represented as phi. So d is the diameter through which the metal is flowing. That is the diameter of the screw, say. And rho is the density of the fluid. And eta is viscosity. A viscous means some which will uh, give some frictional drag, viscous. So viscosity of the fluid is eta. And what is the interpretation? Higher the Reynolds number, greater the turbulence. So if Reynolds number is say 2000, turbulence will be very high.
Yes, yes.
And like
Laminar ito.
yeah.
Mhm.
So if from a I have designed a gate, and later on I am checking the Reynolds number. So mainly velocity and diameter, density I can't control, because for a particular metal, density and viscosity, I don't have any control on that. Steel casting is required. Aluminum casting, I can't control that. But what I can control, I can control the velocity and diameter. Okay, to control the Reynolds number.
Okay, sir.
So that is the design. And another aspect is also required. This is the pouring time, because we have mentioned just now the time temperature curve. Too long pouring time is not desirable. Too short pouring time again is not desirable, because there are some advantages as well as limitations. So how the pouring time is calculated? Again, there are various formulas, but say for example, In steel casting, it is given by this expression. In steel casting, we may have something, some other formula also. So for steel casting, tau is the pouring time in second, tau. It is given by S into delta G to the power 1/3, where delta is the mean thickness of the casting wall. What is that? Say this is my casting. Say this is the casting. So what is mean thickness? Here I have various sizes. This is say T1, another say this is T2, this is say T3, and so on. This is T4, say this is T5, T6, and so on. So all these are different. So mean is T1 plus T2 plus T3 plus T4 plus T6. So in this way, if I have say n different thicknesses, divide that by n. So that is the mean thickness of casting wall in millimeter. And G is the gross weight of the casting in kg. And S is a coefficient which depends on the type of gate. Type means if it is a bottom gate, S is 1.3, for side gate 1.4, and top gate 1.5 to 1.6 for steel casting. If it is aluminum, these values may be different. And pouring time, tau. So pouring rate, what is the rate? Total weight divided by pouring time. So that is rate. So all these are important considerations in case of gate design. Uh, the Bernoulli's theorem, continuity equation, Reynolds number, pouring time, etc. And then riser. Now, before discussing riser, do you want to have some 2-3 minutes break, or we may continue?
আহ, ঠিক আছে, কোনো অসুবিধা নেই, অসুবিধা নেই।
কি কন্টিনিউ করব না ব্রেক?
হ্যাঁ স্যার,
ঠিক
একবার
আছে, 2
ব্রেক
মিনিট
দিন।
ব্রেক। হ্যাঁ, 2
কি?
মিনিটের ব্রেক। 2 মিনিট ব্রেক দিয়ে দিন, তারপর।
হ্যালো, হ্যালো,
হ্যালো স্যার, হ্যাঁ হ্যালো।
হ্যালো, শুনতে পেলাম না।
হ্যাঁ, 2 মিনিট ব্রেক দিয়ে দিন, তারপর আবার স্টার্ট করা যাবে।
2 মিনিটস?
হ্যাঁ হ্যাঁ।
ওকে, ঠিক আছে। ওকে, 2 মিনিটস। হ্যালো,
হুম।
হ্যাঁ বলো।
হ্যাঁ হ্যাঁ।
হ্যাঁ হ্যাঁ, 2 মিনিটের পরে আসি। ওকে, 2 মিনিট, হ্যাঁ ঠিক আছে। Hello,
Yes, sir.
Yes, sir.
hello.
Yes, sir. Yes, sir.
Hello,
হ্যাঁ স্যার,
hello.
বলুন স্যার।
হ্যাঁ, আচ্ছা তাহলে let us start, huh?
ওকে স্যার।
Now, so previously we have observed that uh, you have observed the videos also and workshop video, and perhaps some of you are also undergoing the workshops on Foundry right now. So that time, or during our theoretical discussions also, we had mentioned we use actually two screw pins, tapered plug or a straight plug, two screw pins. One is meant for gate, which is called a runner. Another is used as a riser. Riser, what I told you, that is a reservoir. So up till now, we had discussed about runner, that is gate. Another important part is riser, where riser is nothing but a store or stock or reservoir of molten metal. Because during shrinkage, solidification is a must. Sorry, during solidification, shrinkage is a must. During solidification of the liquid, the metal will shrink. And as it will shrink, that not only the dimension will be altered or deviated, some defects, casting defects like cavities. What are cavities? Those will be discussed. But some casting defects will also be generated. So I must supply some additional metal during solidification to avoid such defects, particularly shrinkage and uh, the defect formation. So that's why this is also known as a feeder, riser or feeder. But very important, you note that star mark with asterisk mark, risers are not that effective for some materials which are having larger freezing range. A freezing range, you know what is freezing range, we had discussed right now in this graph here. Okay, so from molten metal, cooling, then freezing start, freezing stops. So if this freezing range is too long, okay, so in that case, we don't require, or the risers will not be effective, because all the metals will be solidified completely, right? So it may not be so important in those cases.
আচ্ছা।
And in case these are also not needed, where the cavity is filled up by molten metal with pressure. Pressure means pressurized system, like say in case of your our in the last class we had discussed about pressurized casting, centrifugal casting. Centrifugal casting is one special type of casting. Another we had gravity die casting. Gravity die casting, when it is gravitational force, it is not, I mean, foolproof. But when some pressure is applied, so that was the goose neck, goose spot neck was used, right? So in case of pressure, casting, pressure die casting, or when the molten metal is forced to enter in the cavity, in those cases, risers are not that effective. Now, what is the theory behind this riser? Our target is to preserve or store molten metal in the riser. So, it must not solidify at first, okay? The metal in the riser should be solidified. Obviously, metal will be solidified after some time, molten metal. But it should be solidified after the casting, after the solidification of the mold material. Otherwise, its purpose will not be served. Okay. And also, the riser must have enough material to compensate for the shrinkage. Right. So these are the two requirements. And Chorinov, one scientist, Chorinov, the spelling, you mind the spelling, Chorinov, Chvorinov apostrophe S. So Chorinov's, because this is a theory, metal in the riser must cool after the casting and it must have enough metal. So accordingly, based on the theory, Chorinov suggested that slowest cooling rate can only be achieved with largest volume and least surface area. For a geometrical shape which is having largest volume but surface area is least, say a triangle, a cylinder, a cube.
স্যার স্ফিয়ারের তো কম
Sphere.
সারফেস এরিয়া। হ্যাঁ
Now, amongst these, sphere is having surface area, least surface area, but volume is maximum. So ideally, sphere is the ideal shape so far as Chorinov rules is concerned. Chorinov suggested to achieve this condition, that is slowest cooling rate, metal must cool last and it must store maximum compensate. So volume must be very high to accommodate more metal, and cooling is also slow. So which one is the ideal? If I produce a cylindrical shape riser, or a square, or a rectangle, or a pentagon, or a triangular shape, pyramid, any truncated pyramid, a sphere. So out of all these, sphere is having that property, that is volume is largest but the surface area is least. Okay.
ওকে স্যার।
And and Shorinov suggested this formula: solidification time is directly proportional to volume by surface area whole square. T suffix s proportional to V by A whole square, where V is the volume, A is the surface area. And when this proportional sign is replaced by equal to, a constant is coming. And this C is known as mold constant, and depends on the pouring temperature, thermal characteristics, and etc. Okay.
ওকে
So
স্যার।
Yes,
how
sir.
to how to utilize this formula? Later on, I shall tell you. Now, another concept is efficiency or yield of a casting. What is efficiency or yield? It is the total weight of the cast part divided by the amount of metal poured. Okay. Total weight of the cast part, and to achieve that cast part, how much material was poured. So this is the efficiency. And needless to be mentioned, when we uh, consider risers and runners, all these, then all these again will be solidified along with the mold cavity. So extra weight must have to be reduced, right? How it, so what I was telling, this is a real life casting. My casting is this part, this one. This is required, but I must provide some riser here, riser, and these are the gates. Okay, sprue basin, down gate, and all these. So though my requirement is this one, but after the solidification, so many other things are coming. Sprue and risers. So these are the various risers, this runner, all these. So total weight is very high. As a result, efficiency will be reduced. So target is to design the system so as to minimize this riser, runner, all this. That is the optimize here. When risers are used, total weight may be more. So it is important to optimize their size and shape. Okay.
Okay, sir.
Again, as we had discussed gates, top gate, bottom gate, parting gate, here also, based on the position and nature of the riser, we may divide risers in various categories. Like say top riser. If the risers are placed on the top surface, this is the cast part cavity. It is placed on the top. So this is top riser. But here again, the riser is placed here, not here. If it is placed by the side, so this is known as side riser. Side riser. Again, if the if this is the top riser, say top riser, and the upper face is open to the atmosphere, it is known as open riser, open to the atmosphere. But if the riser is placed somewhere here, this is side, not on the top, and the upper face is not opened to the atmosphere, but it is concealed inside the mold cavity. So this is known as blind riser. We may draw a figure here like this. So this is top blind riser, top blind riser. Here, if I draw a figure like this, right? Side open riser. Is it clear? Top blind riser, side open riser, top open, and so on. Open, blind, side, top, another are, so blind riser, another two are live riser or hot riser and dead riser or cold riser. You just observe here. if this is the riser, say, original, so molten metal is poured here. Okay, so as molten metal is entering, this will fulfill all the cavity, and at last this cavity will be fulfilled. So at the end of the pouring, molten metal will enter in the side riser last, and as molten metal is entering last, so the it will remain hot. That's why it is called a live or hot riser. On the other hand, if this is the situation, then as soon as molten metal is poured here, it will flow, and the riser will also be fulfilled by the molten metal at the same time. So when the entire cavity is filled with molten metal, by that time the riser is already filled with metal. By that time it will lose some heat. Its temperature will come down to some extent. That's why it is called dead riser or top riser. Generally, top risers are dead risers or cold risers, right? Generally. So we have 6 types of risers: side, top, open, blind, live or hot, dead or cold.
স্যার
হ্যাঁ,
বলছি লাইভ আর হট রাইজের ওই ব্যাপারটা বলবেন, হিটটা কিভাবে হচ্ছে আর কি, ওটা বোঝা
লাইভ
যায়নি।
রাইটার যে এমনভাবে গেটিং সিস্টেমটা করা হয়েছে, যেখানে রাইজারে মেটালটা লাস্টে ফিল আপ হবে, মানে আগে ক্যাভিটিটাকে ভর্তি করার পরে তারপরেই রাইজারে যেতে পারবে। ঠিক আছে,
আচ্ছা
সেভাবে ডিজাইনটা করেছি, মানে রাইজারে মেটালটা ঢুকবে সব থেকে পরে, এইভাবেই ডিজাইনটা করা আছে। তাহলে সেখানে লাস্টে ঢুকলে সেই মেটালটা হট থাকছে। হট থাকা মানে কি,
Yes.
অনেক পরে যখন ক্যাভিটির মেটালের সলিডিফিকেশন স্টার্ট হয়ে গেছে তখনও ও লিকুইড স্টেটে আছে। এবারে যখন সলিডিফিকেশনের সময় যদি কোনো শ্রিঙ্কেজ হলো, শর্টেজ হলো, যেহেতু ও লিকুইড স্টেটে আছে তখনও, তাহলে ওখানে ক্যাটার করতে পারবে, ওই গ্যাপটাকে ফিল আপ করতে পারবে। দ্যাট ইজ দ্য রিকোয়ারমেন্ট অফ এ রাইজার মেটেরিয়াল। সো দিস ইজ কল্ড লাইভ। অন দ্য আদার হ্যান্ড, এমনভাবে যদি ডিজাইন করা হয়, যখন আমরা মোল্ড ক্যাভিটিটাকে ভর্তি করছি, একই সঙ্গে রাইজারটাও মেটাল নিতে শুরু করলো। সেটা কখন হবে, যেটা সাধারণত টপ রাইজারে। সাধারণত টপ রাইজার মানে কি, ক্যাভিটির ওপরই রাইজারটা থাকছে। সো when mold cavity is filled up, simultaneously the riser is also filled up. তাহলে যখন টোটাল ক্যাভিটিটা ভর্তি হলো, সেই সময় হয়তো দেখা যাবে রাইজারের মেটালের টেম্পারেচারটা অনেক কমে গেছে। সো দ্যাট ইজ ওয়াই দিস ইজ কল্ড কোল্ড অর ডেড।
ওকে স্যার।
কিন্তু as we have mentioned, generally top risers are dead type of rise, dead or cold risers, top risers. But sometimes, to ensure that the top risers are provided with hot metal, molten metal, sometime For some specialized casting, we may use a part which is known as hot tops. This is also a sort of riser. Hot tops. What is that? Hot tops are also say this is a provision for riser, and metal is poured here. This is the cavity. So when molten metal is flowing, it is also entering in this riser. Okay, as this is top riser, so it will become a cold or dead riser. When the total cavity is completely filled up with molten metal, then you insert a pre-prepared riser. Riser is prepared separately outside. How? Using a ceramic liner. So this is a special material, and place this ceramic liner part, that is hot top, and then pour extra material. So instead of preparing what we are doing, when we are preparing the mold cavity, we are ramming the molding sand using riser or runner pin, that is screw pins. So instead of preparing the riser along with the mold cavity, we prepare a ceramic liner riser separately, and when pouring is almost complete, then we place this ceramic liner hot top, and molten metal is filled in this hot top, so that as the liner is ceramic liner and molten metal is poured at last, so it will be live and hot. So though it is a top riser, but the metal remains hot and it acts as a live riser. Generally, top risers are dead or cold type, but depending on the requirement, in some cases for specialized casting, sometimes hot tops are used. These are not riser because this bucket or this reservoir is prepared separately using ceramic liner and inserted at last. That's why the name is hot tops. Function is same, to provide or to cater molten metal during solidification. Hot tops. Now take this problem on riser. Three pieces of metal being cast have the same volume but different shapes. One is sphere, one is cube, another one is cylinder. What is that cylinder? Again, a condition is given. The height of that cylinder is equal to its diameter. It may not be so. We may have some other geometrical sizes also, but here it is given. Now, which one will solidify the fastest and which one will solidify the last? You may consider so many techniques, but here task is to, it is given, discuss considering the solidification time of each. And we know,
স্যার সোভরেনেস রুলটা কি লাগাতে হবে?
হ্যাঁ হ্যাঁ
হ্যাঁ,
এখানে
সলিডিফিকেশন টাইমটা।
এটা যেহেতু we know this is v by a whole square,
হোল স্কয়ার।
but again as we have mentioned that as per Sodinov rule, sphere is having the highest volume to least surface area, but don't answer in that simple way. You will have to find out the solidification time of sphere, ts sphere, ts cube, ts cylinder separately. Okay, and you will have to compare the solidification times. So if you can do this, try. Otherwise, in the class Friday, we shall solve this. So try of your own. Have you got this, or should I send this problem via chat box?
স্যার স্ক্রিনশট নিয়ে নিয়েছি।
Oh, near, good. So now we shall discuss some casting defects. And with this, we shall conclude today. Up till now, we have mentioned about green sand molding technique, some precision or investment casting techniques where shell molding, lost wax process, ceramic molding, uh, carbon dioxide molding, all these techniques were there. And also we had discussed some special castings like mechanized die casting, gravity die casting, then centrifugal casting, centrifuge, etc. All the times we have mentioned, time and again, we had mentioned about various defects. So what may be the defects? If you go through some books, any book, you will find many more, not only this limited few what are observed here. Okay, here only some fewer defects are written. Those are important defects. But if you go through books, you will find so many other also. But these are the important defects. What are those? These are the figures. Like say 1. What is 1? Is shift. This defect 1 is shift. It means that, say this is a cope and drag system. One is cope up and lower is drag up. This shift particularly happens or occurs in case of cope and drag system due to misalignment of the two halves. That's why we must use guide pins, dowel pins, marking the say locating pegs, marking the parts. So in the workshop videos also you have observed all this to ensure proper alignment of cope and drag flask in the parting plane. If it is not aligned, what may happen? Two types may happen. Either the core is shifted here at the parting plane, though outside structure, outside is perfectly circle, but inside there is a shift. So the part becomes weaker. If it is say axle, if it is say some axle or shaft, it may not take that load, desired load. It will fail. Or the core may be perfectly circular, but the upper part here it is shifted. So that is again is a defect. Shift. So how to avoid? Just by using guide pin, dowel pin, locating pegs, marking the parts and all this. Second is warpage. So what this one. Now, if the solidification or cooling is uneven, then this type of bending or distortion in shape may result. So